Our discussion today, this is part one out of two parts, will start with discussing the motivation for cellular Wi-Fi convergence. We'll continue in discussing scheme for cellular Wi-Fi convergence and conclude this chapter by discussing what may be the ultimate or the ideal cellular Wi-Fi convergence scheme. We'll go briefly through the standardization bodies involved with the Wi-Fi cellular conversion, and we'll end this session by describing the Passpoint certification program initiated by the Wi-Fi Alliance, which is one of the pillars of the cellular Wi-Fi convergence concept. Let's start by looking at some interesting data provided by the VNI. VNI stands for Visual Networking Index, published by Cisco, and this is regarded as probably the most reliable source of data for forecasting the usage of data in general and more specifically IP and internet traffic. This graph shows actually the prediction for global internet traffic in the coming years, actually started for 2012, ending in 2017. And if, for example, we look at the bar which relates to, let's say, 2015, we'll see that it is estimated that about 50% of all global internet will be provided using Wi-Fi, and only 8% out of the global internet traffic will be provided by mobile data networks, in other words, by cellular networks. It is also interesting to note that starting this year, 2013, actually most of the data consumed today by users accessing the internet is provided by wireless connections and not through wired connections. The previous data is strengthened by looking at data gathered a year ago, during September 2012 to December 2012. As can be seen in this graph, the traffic volume provided through Wi-Fi is almost 5 times the traffic volume provided through cellular networks per average user. And actually, this is not surprising. This information just supports and provides numbers to something that we all know. Wherever we want to consume big chunks of data, we usually prefer to use Wi-Fi over cellular. Cisco VNI forecasts that cellular service providers will be able to harness Wi-Fi to their needs, and actually, on 2017, about 46% of the traffic originally meant to be used through the cellular RAN will be diverted to Wi-Fi. What does it mean? Does it mean that cellular carriers will give up about half of the revenues? Maybe they have no choice, and their networks just cannot supply the exponential growth in demand for data. So in other words, they will have to give up significant portion of the traffic to the Wi-Fi networks. Or maybe it can be interpreted differently. Maybe we may say that the carriers will find a way to divert only a portion, or just a portion, of the huge volume of the data that run through the Wi-Fi networks to their pocket core networks, and through them to the charging systems. Or maybe not all bits are equal. Maybe some bits value more than other types of bits. For example, bits which relate to file transfer may equal less than bits which relates to augmented reality application. So maybe the carriers will find smart ways to differentiate between these two services and divert the less value bits to the Wi-Fi network and monetize on the higher value bits. As of today, once the subscriber uses the Wi-Fi network, the operator cannot monetize this traffic, or have the visibility into what this subscriber is doing. On the other end, the mobile service provider does not have the capacity for delivering the volume for the data which is currently delivered to the Wi-Fi. More than that, he may wish to transfer data to the Wi-Fi network in order to avoid congestion in a cellular network. The cellular service provider has two contradicting wishes. On one end, he wishes to be the default or even the sole voice and data service provider, maintain his position in the value chain, and have a visibility and control over the customer's experience. But on the other end, he doesn't have the capacity to be an alternative to the Wi-Fi channel. So offload is a kind of possibility that is put now on the table of service providers, and they need to decide whether to use Wi-Fi offload as one tool, probably a significant tool, in their toolbox. So how Wi-Fi offload can be used? There might be several strategies or several benefits that the service provider may consider. The first, and this is the most understood, is actually to overcome congestion in his cellular network. For example, peaks, in busy hour peaks or peaks related to specific sites where some people consume suddenly large chunks of data. This actually may overload the cell and avoid a proper service to the cellular subscribers. So by using Wi-Fi offload, actually it is possible to cut these peaks and actually design the system for average and not for peak. So in case of unloaded system, all traffic may go through the cellular network with all the control mechanism that exists with the cellular network, all the charging mechanism that exists there, and quality of service will probably be okay since the system is not loaded. Whenever the system is loaded in a peak hour, some of the traffic may be diverted to the Wi-Fi network. So this is one motivation actually for cutting the peaks and being able to deal or to cope with sudden congestion in the system. Another motivation actually relates to coverage. In some cases, Wi-Fi may be a tool for providing just coverage. For example, in-building coverage. And by actually taking advantage of the fact that Wi-Fi is usually installed inside buildings, and almost in every building there is a Wi-Fi coverage, the system, the macro system, actually can relieve or divert traffic that is intended to in-building users to the Wi-Fi network which is installed in the building. And by that, relief from the macro network the in-building user. This will enable better utilization of the macro base station radio sources. As we know, with 3.5 and 4G technologies, removing a slow subscriber which is served with low spectral efficiency may result in freeing enough resources for serving multiple faster subscribers. As mentioned before, not all bits are equal. Some services may be more profitable or chargeable than others, and Wi-Fi offload may be a way to get rid of the low-value bits, divert them to the Wi-Fi, and monetize on the high-value bits that run through the cellular radio access. For example, the service provider will prefer to offload the less profitable file transfer service and serve the more profitable augmented reality application. And of course, quality of service or quality of service requirement must be considered. The service provider may decide to offload to Wi-Fi the less sensitive services, such as file transfer, web browsing, and even video streaming, and retain in the cellular network the services that require tight quality of service mechanisms, such as voice and video calls. When discussing mechanisms for supporting Wi-Fi cellular convergence, we may want to distinguish between client-based solutions and clientless solutions. In the client-based solution, the convergence applications is actually preloaded or downloaded to the mobile device. For example, AT&T may provide or may encourage its customers to download to their mobile devices the AT&T Smart Wi-Fi application, which enable them to connect easily and seamlessly, as much as possible, to their Wi-Fi network. In the case of a client-based solution, the application is tailored to a specific network configuration and capabilities. In a client-based solution, it is possible to overcome some issues that were not solved yet by the standardization. But on the other end, features and capabilities might be limited to the network and to the mobile unit devices. And of course, the distribution and the activation of the application that need to be preloaded or need to be downloaded by the user might be a challenge. In the case of clientless solution, convergence is supported by the native protocols. It means by the Wi-Fi and the LTE standards. And there is no need to separately preload or download an application. And of course, there is a strong dependency on the availability and maturity of standards, because it is relied on the existence of native Wi-Fi and LTE standards. However, when the standards will be in place and the networks and the mobile devices will comply with them, optimal solutions may be achieved. So in this discussion, in this tutorial, actually we will mainly focus on clientless solution. In other words, in solutions that are supported by the native Wi-Fi and LTE standardization. Okay, another distinction we may want to make is between loosely coupled networks and tightly coupled networks. In loosely coupled networks, the decision to move from cellular to Wi-Fi is initiated by the user. In this case, the traffic is diverted directly to the internet. In the case that the user decides to move to Wi-Fi, the traffic is diverted directly to the internet. It doesn't go through the cellular core network. When moving from cellular to Wi-Fi, if it is done during a session, the IP continuity may be lost. The service provider may use either Passpoint and/or ANDSF. We'll discuss Passpoint in the coming slides, and we'll discuss ANDSF in the next tutorial. The service provider may use these two set of features, or these two mechanisms, for distributing information on available networks and policies that guide traffic steering decisions. In tightly coupled networks, toggling between the 3GPP cellular and Wi-Fi and vice versa is controlled by the cellular service provider, by mechanisms that are embedded in the core network. The decision will probably be based on which radio access technology may provide the best quality of experience. In this case, a common core, and this is the cellular core with some additions, serve both the Wi-Fi and the cellular radio access technology. With tightly coupled networks, it is possible to configure the core network in a way that will preserve the IP address continuity when the user actually moves from cellular to Wi-Fi and from Wi-Fi to cellular in a way that IP continuity will remain.